Today's topic is rate of flow or discharge. So first we discuss about what is rate of flow or discharge. It is the amount of fluid flowing per second through a section of pipe or a channel. That means how much amount of water is flowing or any type of fluid is flowing. That may be water, oil, whatever may be, and a fluid that is flowing in a pipe or channel per second, we can say that is rate of flow or discharge. It is denoted by term Q. So that type of discharge we measure in two types of fluid. One is your incompressible fluid, another is your compressible fluid. In incompressible fluid, we can measure in terms, in incompressible fluid, measure in the terms of volume of fluid flowing across the section per second. But in for compressible fluid, we measure in terms of weight of fluid flowing across the section. So in two types of fluid, one is your incompressible fluid, another is your compressible fluid. In incompressible fluid, we measure in terms of volume of fluid per second, but compressible fluid, we measure in terms of weight of the fluid flowing across the section. For liquid, we measure the discharge in terms of meter cube per second or liter per second. Meter cube per second or liter per second. But for gas, we measure the discharge in terms of one is your kg force per second or Newton per second. So how can we measure? First we know its formula. So the formula for discharge is Q equal to A into V. So we know the term Q equal to A to V, A equal to what? Area of the pipe, area of the pipe or channel. V equal to velocity, that is measured in terms of meter per second, in which velocity the water is or any fluid is flowing. Then Q equal to discharge. So Q equal to area into velocity. So that is the formula. That is the formula for measuring the discharge. So next we go for the continuity equation. Continuity equation. So what is continuity equation? This equation is based on principle of conservation of mass. Continuity equation is based on principle of conservation of mass. So the equation based on the principle of conservation of mass is called continuity equation. So how can you use in the pipe or in a channel when water or any type of fluid is flowing? So for the purpose, we consider a cross section or a cut section of a pipe or channel when water or any type of fluid is flowing. So then that continuity equation is based on the continuity equation is based on the principle of conservation of mass. So for the purpose, we consider a cross section or a cut section of a pipe or a channel. So what are they? So we consider two sections, section 1 section 2 section 1 section 2. This is a pipe or cut section of a pipe or channel of varying cross section. So here we consider section 1, another is your section 2. So this is your direction of flowing. Direction of flowing. So here we consider two sections. So we consider the term. Here three terms. One is your A1, V1, rho 1. A equal to, you know, area of pipe, area of pipe at section 1. Another V1 equal to average velocity at cross section 1. Similarly, rho 1 equal to density of fluid at cross section 1. Similarly, we consider for section 2 A2, V2 and another is your rho 2. So A2 equal to what? Area of pipe at section 2, then V2 equal to average velocity at cross section 2, density of fluid at section 2. So here we consider the following terms. One is your A1, V1, rho 1 at section 1, A2, V2, rho 2 at section 2. A1 equal to area of the pipe at section 1, V1 equal to average velocity at section 1, rho 1 equal to density of fluid at cross section 1. Similarly at section 2. So according to your continuity equation, the rate of flow at section 1 equal to rate of flow at section 2. So in section 1, according to continuity equation, the formula is rho 1, A1, V1, then rho 2, A2, V2. But here same fluid is flowing in a pipe. Then what happen? So your density of fluid at section 1 and density of fluid at section 2 is same due to same type of fluid is flowing. So rho 1 equal to rho 2. So the equation is reduces to A1 V1 A2 V2. So this is your continuity equation. So in the next class we solve the problem about the continuity equation. So again we focus on the about the class what is rate of flow or discharge. That means how much amount of fluid is flowing in a pipe per second. So we did two terms or two types for incompressible fluid, for compressible fluid. For incompressible fluid, we can describe the volume of fluid, how much volume of fluid is flowing per second. For compressible fluid, we discuss about the weight of the fluid per second. For liquid, we can take the unit is meter cube per second or liter per second. So here one question arises: 1 meter cube per second equal to how much liter per second? That is 1 meter cube per second. That is 1000 liter per second. We said 1 meter cube per second equal to 1000 liter per second. So similarly 1 liter per second equal to 1 by 1000 meter cube per second, or we can say 0.001 meter cube per second. So 1 meter cube per second equal to 1000 liter per second, or 1 liter per second equal to 1 by 1000 or 0.001, or we can say 10 to power minus 3 meter cube per second. That is the unit conversion. For discharge, we take the term Q. It denoted in the term Q. So the equation is Q equal to AV. So for proof how the term come Q equal to AV, we take a cross section of a pipe or cut section of a pipe or channel. It is based on the which equation? It is based on the continuity equation or principle of conservation of mass. Principle of conservation of mass. Your first law of thermodynamics is based on the principle of conservation of energy, but your continuity equation is based on the principle of conservation of mass. First law of thermodynamics, conservation of energy, or your continuity equation is based on the principle of conservation of mass. So here we take a cross section of pipe of varying cross section. So for calculating its formula or for derivation, we take two sections, section 1 section 2. So according to conservation of mass, how much amount of mass is flowing at section 1 equal to similar at section 2. So for the above, we take the consider three terms: A, V, rho. For section 1 that is A1, V1, rho 1, and 2, A2, V2, rho 2. A1 equal to area of the pipe at section 1, V1 equal to average velocity at cross section 1, rho 1 equal to density of fluid at cross section 1. Area equal to, we can take the unit that is meter square, velocity the unit is meter per second, and your density equal to unit is meter kg per meter cube. Similar at the section 2. So when you according to conservation of mass, section flow at section 1 equal to flow at section 2. So rho 1 A1 V1 equal to rho 2 A2 V2. Rho 1 is cancel because similar fluid is flowing. For case of the compressible, the density is changed. For incompressible, the density is same for section 1 and 2. So the equation is reduced to A1 V1 equal to A2 V2. This is your continuity equation, or we can measure in terms of rate of flow or discharge. So rate of flow or discharge equal to how much? Rate of flow or discharge equal to, you can say, Q equal to A1 V1 or A2 V2. Thank you.